So, hello friends at home, we sure are missing you, and we have a great class in here for Mrs. Baxter's class. We're going to work for our math lesson here together, okay? You guys are going to be extra quiet so they can hear you, okay? All right, so we're going to start by using the distributive and the commutative property to find math facts. So the first thing I want you to do on your whiteboard is draw 1 7. How many 7s do we have? 1 7. Let's add another 7. Now how many 7s do we have? 2 7s. Please dress up your numbers. Let's add another 7. How many 7s do we have?
3 7.
Go ahead and continue to draw 7s until you have 5 7s. So I have 3, now I have 4, now I have 5. What multiplication fact would be right to find the total for 5 7s, Ellie? Very good. We would write 5 times 7. That would mean we would have to skip count by 7 5 times. And we're just learning to skip count by 7, so that's difficult. But what other math fact can help us find 5 times 7? Don't forget about our commutative property. What one, Yvonne? Flip them, and so then we would have 7 times 5 if we rotate our factors. Now we all know how to skip count by 5, right? Go ahead and skip count 5 7 times, class. 5, 10, 15, 20, 25, 30, 35. So our answer would be 35. So if our answer for 7 times 5 is 35, then our answer for 5 times 7 is also 35. What did we just use that helped us? The commutative property. Very good. Now, let's use this familiar fact, 7 times 5, because we all know that pretty well, right, Carson? We all know 7 times 5 equals 35 really well. What if I add one more 7 up to the top? Let's go ahead and do that. Now how many 7s do I have? I no longer have 5 7s, I have 6 7s. Thank you, Luke. I now have 6 7s. So what math fact would I write for this? I would write 6 times 7. Now I know you all know that already because of my awesome poster up here in glitter, but let's use the distributive property to help us with this. Really, we have 5 7s here, and we have added 1 7. Thank you, Luke. So what does that mean? 6 7s is the same as, whoops, 5 times 7 plus 1 times 7. What does the 5 times 7 represent? The bottom part of our picture. What does the 1 times 7 represent? The top part of our picture. And now let's see how knowing 5 times 7 can help us. Well, what is 5 times 7, class? It is 35. We already did that work. And to that, we're going to add 1 times 7. That's easy peasy. That is 7. And what do you get when you add 35 and 7 together? You get 42. Guess what 6 times 7 is? It's 42. We know that from our awesome poster. So what did we do, boys and girls? We took this back 5 times 7 when it was hard for us to skip count by 7. We used the commutative property so that we could skip count by 5. And then all we had to do is add one more 7, and that is the distributive property. We broke 6 7s up into 5 7s plus 1 7. Now, let's just do that with unit form, okay? Tommy up here. To do the same thing, but instead of writing with our facts, say how many 7s do we have all together? Madison? How many 7s do we have all together? We wrote it with math facts, now we're going to write it with unit form. Look at the picture. How many 7s do we have? We have 6 7s. So let's write it like this. That's unit form, right? 6 7s? Can everybody write that on the board, please? 6 7s? And what do we say? That equals, well, how many 7s do we have below the line? 5 sevens. So that equals 5 sevens. What does 5 sevens represent? These 5 right here. And then to that, in order to get 6 sevens, we have to add 1 7. So 6 sevens equals 5 sevens plus 1 7. Okay? And we all know, again, if I wrote that multiplication fact form, it would be 5 times 7. 1 7 would be 1 times 7. I could keep going. 5 times 7 is 35. 1 times 7 is 7. If I add those two, I get 42. So what is 6 sevens? 6 sevens is 42. Okay, erase your boards. Let's try it with another one. No talking, please. No talking, please. All right, let's do this one. What unit are we going to count? We're going to count nines. Okay? Go ahead and draw 6 nines. 6 nines. There's 1 9, 2 nines, 3 nines, 4 nines. I want you to do it like this. 4 nines, 5 nines, 6 nines. And I'm going to count again, make sure I have 6. 1, 2, 3, 4, 5, 6. I've got 6 nines. Now, what's that familiar math fact that we all of us have passed already? What is it? It's 5s, right? So instead of trying to do 6 nines, let's decompose this right here. And now I have 5 nines down here and 1 9 up here, don't I? So what did we do? This is important, boys and girls. Write this. We have 6 nines equals or is the same as what? Well, what do we have below our nut line? 5 nines. Oh my goodness, you guys are getting it. 5 nines plus 1 9. 5 nines plus 1 9. Does everybody see how this number set in unit form matches my picture? Well, now let's change those into a fact. So we have 5 times 9 here, right? But I don't want to count on by 9s. I want to count by 5. So let's use the commutative property, and instead of doing 5 times 9, let's do 9 times 5. And then you guys can all skip count by 5 9 times. Go ahead and do it in your head. And what will you get if you skip count by 5 9 times? Whisper that answer to your neighbor. What will you get? I heard a lot of people say 45. Is that correct? Sure is. 9 times 5 is 45. And if 9 times 5 is 45, guess what? 5 times 9 is also 45. All right, let's turn this unit form into fact form, because fact form is a little bit easier to work with. How do I write 5 nines as a multiplication fact? I write it as 5 times 9. Go ahead and write that under your 5 nines. You really need to set up your board like I have mine set up. And then to that, we're going to add 1 9. How do we write 1 9 as a multiplication fact? We write 1 times 9. Okay, we've already done the work. What is 5 times 9, class? 5 times 9 is 45. And oh my goodness, 1 times 9, that's easy. That is 9. And what do we get when we add 45 and 9? Take a second and do that in your head. 45 plus 9 is 54. Well, guess what 6 nines is? It is 50. So in other words, this part is 45. This part is 9. We're going to add 9 and 45 to get our total of 63. Does everybody see that? Let's try it one more time. Try to set your board up like I have mine set up so you can show all the same work. So it's probably best to have it horizontal, okay? Okay, let's try one more. We're going to do 6s this time. Erase your board. And you probably know how many 6s I want you to draw. I want you to draw 6 6s, okay? So go ahead and draw 6 6s. I wish you would do it. See, you have another extra 6 sixes without 30. Need 6 very good. See, if you could write this one all the time. Well, this. All right, well, where do you think I'm going to decompose this? Because what easy factor we've been using so far all day today, Devon? 5. So I'm going to count 1, 2, 3, 4, 5. I'm going to put my little line there to decompose my 6s, Thomas. Put the little line to decompose your 6s. And now how many 6s do I have? I have 5. So that would be 5 times 6. What if I don't want to skip count by 6s? I can use my commutative property and do 6. So go ahead and do 6 times 5 and find out what that is. Skip count by 5, 6 times. Did you write these down? You need to write those down. I don't know the answers. I want you to write those down. Okay, who has what 5 times or 6 times 5 is Amelia? 30. And so if 6 times 5 is 30, then 5 times 6 is also 30. What's that amazing property? You learn one fact, you get one free. Everybody, it's called the commutative property. Okay? But I don't really just have 5 6s, I have 6 6s. So let's start with our unit form. All together we have 6 6s, right? I'll give you a second to write that. Oh, some of you know exactly what to do. That equals 5 6s, which represents the bottom part, plus 1 6. You guys could probably teach this. Does everybody see how we decompose 6 6s into 5 6s plus 1 6? Okay, what math factor are we going to write for 5 6s? I don't really want to use unit form. It's too long. It's too cumbersome. It's not very efficient. So what math factor will we write, Gavin? Yeah, we'll replace that with 5 times 6. Put it in parentheses so you know that fact goes together. You doing all this, Nathan? And then what am I going to add? What math fact can I use for 1 6, Henry? 1 times 6. Very good. Now underneath here I can put my products. 5 times 6 is what, Tommy? Yeah, we already got that over here, didn't we? Nice job. And then what is 1 times 6?
Is 6.
Yeah, there we go. Now that's really easy to add. 30 plus 6, Devon, is 36. Nice job. Excellent. So what is 6 times 6, class? 6 times 6 is 36. We got it by using a familiar 5's fact and then decomposing all our 6's into a 5, 6, and a 1, 6. Yes, Isaac?
It was too easy because it was a round number and we just added them
Yes.
together.
Yes, it was really easy to just add. Easy. Numbers that end in 0 are good numbers for mental math. Okay? All right, now, boys and girls, please get out your workbook. We're going to put this to the test. We're going to do some workbook pages. Start with page 6 in your workbook. Now, I'm not going to bring it up on the clear text because then our classmates at home can't see it. So I'm going to put it under the Elmo. Yes. Go get it. Go ahead. Got your workbook, please go get it. Boys and girls, our friends at home are trying to work. All right, boys and girls. So everybody should be on page 6 in your workbook. So friends at home, what I would suggest, this will be uploaded for you to do. And then what I would suggest is you go back and forth between this open on your laptop and the video recording. Okay? So each cube has a value of 7. Let's circle that. Tommy, can you please be quiet? Thank you. So each cube has a value of 7. So you know what I'm going to do to make my picture more clear? I'm going to put a 7 in each one of those. Go ahead and do that. Put a 7 in each one. And now they want us to write in unit form how many 7s we have. Well, we've got 1, 2, 3, 4, 5. How do we write that in unit form? We use the word, don't we? We have 5, and the unit we're counting is 7s. Now, let's change to fact form, because we're not always going to want to write in unit form. So, the fact form would be 5 times 7 equals 7 times 5. Because remember, if we don't have to skip count by 7s, because we would prefer to skip count by 5s, we can do 7 times 5. Well, go ahead, boys and girls, and skip count by 5 7 times. What will you get? One, 2, 3, 4, 5, 6, 7. What do we get, everybody? 35. Now, could we have skipped counted by 7s? We absolutely could have. We could have done 7. Yes, you may go. Plus 7 is 14. Plus 7 is 21. Plus 7 is 28. Plus 7 is 35. We could have done that as well. It's just not quite as easy as skip counting by 7 or 5. I would rather not do that right now. Carson, I'd rather be doing this, just put it on the ground or something. All right, Kendall, can you slide that up? So let's go on to the next one. Can I remind you that we're recording, Carson? All right. These are still 7s because that's what the direction says. So go ahead and label each unit as a 7. I think Devon is already doing that. Right? But we no longer have 5 7s. How many 7s do we have, Kevin? Count them. We have 6 7s. Very good. And so that's what they wrote, 6 7s equals. Well, let's count the gray ones first. What do we have with gray 7s? We have 5 7s. But now we added, what class? We added 1 7. Where did they get the 35 from? Well, we already know that 7 times 5 is 35, so we know 5 times 7 is also 35. What is 1 7, class? It is, what is 1 7, everyone? 1 7 is 7. 35 plus 7 is 42. What is the total of 6 7s? 6 7s is 40. Okay, well, what math fact will we write for this? What math fact would you write for 6 7s? Henry? Yeah, very good. 6 times 7. Why? What does the 6 represent? The 6 equal groups. What does the 7 represent? The size of each group. What does 42 represent? It represents the total. Nice job. But we could also flip-flop that, and we could, with using the commutative property, what's the other fact we could write? Madison? Equals. You are awesome. Very good. So right here is our commutative property. This was our distributive property because we found what 5 times 7 was, and then we added 1 times 7. How does everybody feel about that so far? Fist 5. 5 means you could teach it to somebody, so let's be very honest. All right, let's go on to the next page. Kendall, if your work is done, you could slide that up for me. You need to write the other fact down. You need to write both those facts, so she's going to change it. You got to keep up with nobody closer to the front than you are, Kevin. All right, let's go to the next page. Oh, now we're counting 8s. So let's go ahead and circle that. Each dot has a value of 8. Let's circle that. That's really important. And how about we go one step further and put an 8 in each one of those dots? Does everybody agree that's a good idea? So let's put 8 in each one of these. And I'm guessing, I haven't counted them yet, but I'm just guessing they probably gave us 5 eighths because 5s are familiar facts. And if I count 1, 2, 3, 4, they absolutely did. They gave me 5 eighths. So what is my unit form for this? 5 eighths. Remember, unit form, you write the word out because the unit we're counting is eighths. You need to keep up. And we're counting 5 of them. Well, what 2 facts can we use? I want a multiplication fact. How do we say 5 eighths is a multiplication fact? Devon, it would be 5 times 8. Yep, and if we flip-flop it, using the commutative property, we would have is the same as what times 5, everybody? 8 times 5. Very good. Well, I don't want to count by eighths. I would rather count by 5s. So go ahead and count 8 5s, and what will your answer be? I like the way I see Celia using her fingers. Some of you might have it memorized. 8 times 5 is 40. 8 times 5 is 40. Okay, and if you want, you can even show your work. 5, 10, 15, 20, 25, 30, 35, 40, and how do I know to stop? Because I got 1, 2, 3, 4, 5, 6, 7, 8, 5. Okay? So we use the commutative property here. The next step, we're going to use the distributive property. Okay? So, can you slide that up for me again, Kendall, please? I appreciate it. All right, here we go. It says use the fact above to find 8 times 6. Well, first thing I'm going to do, since we're counting eighths, I'm going to change this to 6 times 8. Can we all agree we want to continue to count eighths? So let's change this to 6 times 8. Let's change this to 6 times 8. And then let's go back and let's draw those 5 eighths like we had. Okay, we got our 5 eighths, right? But we don't want 5 eighths, we really want 6 eighths. So let's draw our little line and add another 8. There's the distributive property, boys, girls. We decompose 6 eighths into 5 eighths in 1. Well, we already found out what this equals, but what math fact would we write for the bottom part of the array? It's 5 eighths, right? Gavin, what math fact would we write? Yeah, 5 times 8. Very good. And we already figured that out up above. What is 5 times 8, everybody? It is 40. What math fact would we write for the top part of our picture? Lily, what would we write? 1 times 8. Very good. And that equals 8. And now really to get our answer, what do we got to add? We got to add our 2 products. We would add 40 and 8. You got all that done, Liz? So really, boys and girls, let's start with our unit form, okay? We got lots of room. Let's write 6 eighths, because that's how many we have. And how did we decompose our 6 eighths? We decomposed it into 5 eighths. And then we added 1 8 at the top. You guys are doing awesome with this. Okay, because the unit form is so cumbersome, let's change those into facts. So what am I going to replace 5 eighths with? Isaac?
We'll replace 5 eighths with 5 times 1.
5 eighths.
5 times 8.
Yeah, 5 times 8, very good. And then what will we replace 1 8 with? I want a fact. I don't want unit form anymore. Madison. 1 times 8. Nice job, you guys. And then we've already done all the work. What is 5 times 8, everyone? It is 40. Keeping up with us? And what is 1 times 8, everybody? It is? 1 times 8 is? 1 times 8 is? 8. 1 times 8 is? 8. And now I'm going to add those two. What does the 40 represent? The bottom part of our picture. What does 8 represent? The top. Devon, what do we get when we add 40 plus 8? We get 48. Very good. So what was our strategy? First, we found 5 times 8, and then we added one more 8. Okay, let's try this again. I'm going to give you a second to copy that. I'll go back and change it myself. All right. Here's a word problem, and they want us to use a 5-fact to solve. So we want to have 5 units. All right, let's read it and underline our notes for our read, draw, write, boys and girls. An author writes 9 pages of her book each week. So let's underline that. 9 pages of her book each week. How many pages does she write in 7 weeks? And in our question is our other known, 7 weeks. So I'm going to ask you, I know you don't have a lot of space, but we're going to have to draw how many 9s? If there's 7 weeks, how many 9s are we going to have to draw? 7. Thank you, Brian. So let's start with our 5. So I'm going to draw 1, 2, 3, 4, 5, 6, 7. So make sure that you can fit them in a nice row like that. If you have a nice column, if you have to make them smaller circles, go ahead and do that. What's going to go inside each one of those circles? Those are my 7 weeks. How many pages does she write each week? 9. So let's go ahead and put a 9 inside each one. Now it wants us to use a 5-fact to solve. So we've already done it a couple times. Does anybody have a suggestion on how we can use a 5-fact to help us with this? What could we do? Devon? We could write the line after 5. Very good. 1, 2, 3, 4, 5. Let's write the line right there and decompose it. See, that's when you need it. All right, so what math fact are we going to write for this, Gavin? 5 times 9. I don't want to skip town by 9s. It's too hard. I'm just learning. So I can use the commutative property. What other fact could I use, Ryan? 9 times 5. Very good. And then I think you all know what 9 times 5 is? 45. And so that also means that 5 times 9 is 45 because of our good old commutative property. Okay, what math fact will I write for the 2 9s above the line? Lily, what math fact will I write for the 2 9s on the top? I don't see 5 9s. Oh, do you see 5 9s? What will we write? 2 times 9, very good. And what is 2 times 9? You know that, boys and girls, because you all know your doubles, right? What is 2 times 9, everybody? It is? 18. Very good, excellent. So let's look and see what we did here. We took 7 times 9. Does everybody agree? 7 times 9 would be all the 9s? Go ahead and write it. And we decomposed it into what? 5 times 9 for the bottom. Remember when we used to do this? B represents the bottom part. So you really have to write small. And then to that, what we're going to add? We're going to add the top, right? The top is represented by 2 times 9, which is the top. And we've already done the work, right? What is 5 times 9, everybody? It is 45. What is 2 times 9, everybody? It is 18. Go ahead and do the math. Add 45 and 18. And see what you come up with. your algorithm, boys and girls, somewhere in your page, but I want everybody working on 45 plus 18. Who has done 45 plus 18? Several people has. Who would like to share their answer? Henry, would you? How many people got 63? Very good. 45 plus 18 is 63. So boys and girls, guess what 7 times 9 is? 7 times 9 is 63. Very good. Now all we need is a TS. How many pages does she write in 7 weeks? TS. She writes, how many pages, class? 63 pages. In 7 weeks. So, friends at home, remember, you can watch the video, you can flip back and forth between the video and the worksheet I uploaded for you to help you with this. We're going to do number 4 on our own, everybody in class, so I want you to do it on your own as well. Number 4 is just a regular old word problem with read, draw, write. It really doesn't have anything to do with the commutative property or the distributive property. I want you to read it and underline your notes. Matter of fact, Kendall, will you slide that up for a minute for me? Slide it up so we can see problem 4. Thank you, honey. So let's underline this together. Underline the notes. It says, Mrs. Gonzalez buys a total of 32 crayons for her classroom. How many crayons does she buy? 32. What else do we know? Each pack contains 8 crayons. So we know she buys a total of 32, and we know each pack has 8 crayons. And our unknown is how many packs of crayons does Mrs. Gonzalez buy? I want you to draw a picture, write a number sentence, and write a target sentence. So friends at home, I want you to do the same thing. Draw a picture, write a number sentence, and write a target sentence to figure out how many packs of crayons Mrs. Gonzalez buys. Okay? Have a great day, everybody.